Good day everyone. Before I introduce myself, I hope everyone is safe and healthy with their families at home. So, I'm Carmelo Louise Alcala from BSIMT2A. We have given a task from our instructor Sir Michael Pabustan from our subject Airframe System Lab. We have given a task to discuss a certain topic from our subject. But before I will discuss the topic that I choose is I will have some introductions in aircraft ice and rain protection. So, how ice build up on an aircraft? There are two ways how ice build up on an aircraft. The first one is in flight, the second one is on ground. So, why aircraft ice and protection is important for our aircraft? Because ice and rain protection consists of systems to protect aircraft from ice formations. So, let's proceed. There are 4 types of ice. The first type of ice is clear ice. Clear ice is formed by large droplets and it is very cohesive. It is difficult to break loose. And the second one is rime ice. Rime ice is not very cohesive. It is easy to break loose and it is formed by small droplets. And the third one is mixed ice. Mixed ice is mixture or combination of the two ice, the clear ice and the rime ice. So, the last ice or the fourth ice is the frost ice. Frost ice is ice crystal deposit formed by sublimation. So, these are the 4 types of ice that can form in an aircraft. So, let's proceed. There are 2 basic systems of aircraft ice and rain protection. The first system is anti-icing system. Anti-icing system is used to prevent ice formations from the aircraft surfaces. The second one is the icing system. The icing system is used to remove ice formations from the aircraft surfaces. So, this is my introduction, some few introductions from aircraft ice and rain protection. So, we will proceed to the main topic that I will discuss. The main topic that I will discuss is areas and effects of ice formation. I will discuss the effects of ice formations in the different areas of the aircraft surfaces. So, the first area that I will discuss is leading edges of the wings and tail assembly. We all know that the wings of the aircraft and the tail assembly is in airfoil shape. And when ice is formed in this area, it will affect the shape of the airfoil. So, if the ice reaches the maximum camber of the airfoil, the airflow will be disrupted. So, when in flight, when ice is forming these areas, it may cause to higher stall speed. And drag will increase, lift will reduce. So, in this area, we use the system wing anti-ice. The next one is windshield or flight deck windows. So basically, when ice is formed in this area, it reduces the visibility of the pilot. It is difficult for the pilot to see from the windows or flight deck windows. So, the system used in this area is windshield wiper system. windshield wiper system is used to remove ice formations. The next one is antennas. Antennas is used to transmit or receive electromagnetic waves. Antennas is used to communicate. So, when ice is formed in these areas, there will be malfunctions of radio equipments. So, it will disrupt radio communication. It is difficult to the pilot and tower officers to communicate to each other. So, the system used in this area is air data sensor kit. So, we'll proceed to the next one. Propeller blades. It is very impossible to see ice formation in propeller blades when it is in flight or when it is rotating. So, but we can possibly see, or we can see ice formations from hub dome. So, when you see ice formations in ice dome, from hub dome, it indicates propeller icing. So, it will cause the ice from the propellers will cause vibration. Why? Because the ice from the propeller blades will be thrown to the fuselage or body of the aircraft, and it will cause two vibrations. Vibrations will cause two distractions, but vibrations indicates propeller icing. So, when ice is forming these areas, the forward motion and the thrust is affected. So, the aircraft will be hard to do the forward motion. So, the next area is pitot tube. Pitot tube is used to activate airspeed indicator. So, when ice is formed inside the pitot tube, it constricts the flow of the air. So, when it constricts the flow of the air, the airspeed reading will be inaccurate. So, it's hard to the pilot to land because the airspeed is inaccurate. So, we use the system pitot probe heat to remove or to prevent ice from the pitot tube. The next area is the carburetor. Carburetor is part of the engine. So, when the ice is formed in this area, the ice constricts air passage. So, it may result to loss of power or engine failure. So, while in flight, when ice is forming this area, the airspeed may drop. So, that's all. That's all the effect of ice formation in the certain areas of the aircraft surfaces. So, in general, it is important to remember that ice reduces the overall aerodynamic efficiency of the aircraft. The general effect of ice on aircraft is it increases drag, reduces lift, higher stall speed, greater fuel efficiency, greater fuel consumption, and maneuverability is greatly reduced. And also, the weight increases. So your best defense against ice formation on the aircraft is to know and where ice forms and how to avoid it as possible. As we aircraft mechanics, it is very important to us to know how and where ice forms and how to avoid it as possible. It is our job. So I hope you learn from the topic that I discussed. Thank you.